Okay, we are now on question 5 in paper 1. Now, this one here is let f of x be equal to minus x squared plus 4x plus 5. And g of x should be equal then to minus f of x plus k. Find the values of k so that g of x equals 0 has no real roots. Well, okay. Before we get too deep into understanding this, why don't we start with the basics? F of x here, this is clearly a parabola. This is clearly some kind of a quadratic because we have x squared, then we have a 4x, and then we have plus 5. That's very quadratic looking. G of x, because it just takes f of x, is probably also going to be a quadratic. But why don't we examine very specifically what it'll be equal to? We'll just do that in detail. So let's take minus f of x. What is that? Well, that should be minus on this minus x squared. So this should be plus x squared now. Then we would have minus on this plus 4x. That should be minus 4x. And then we have minus on the 5, so it should be minus 5. Now it also says plus k, so I need to include a plus k here. So this is our g of x. Now, what we would like to do is we'd like to find the values of k so that g of x equals to 0 has no real roots. We would basically like it to be that g of x equals to 0 has no solutions or no real solutions. We don't deal with complex ones. Although, of course, if you'd like to, they make a great topic for an IA. So please ask me about them at any chance that you get. So no real solutions. So, okay, fair enough. When do we have no real solutions? Well, the way that I would go about this, because of the way that I think, is that I think to myself, well, the discriminant. When the discriminant, excuse me, when the discriminant is less than 0, that's when we have no real solutions. This is a basic fact about quadratics that I hope you can remember. The discriminant. Now, what is the discriminant? Well, the discriminant is b squared minus 4ac. You can find it many places. It sort of appears in the formula booklet, but you do have to look a little bit carefully for it. But okay, so let's consider that and think, okay, so we're looking for a case where this is less than 0. Well, what is our B? What is our A? What is our C? I'm going to color code them so that we can identify them above. I'm going to make this one red, I'm going to make this one green, and I'm going to make this one blue. So first off, the B. The B is what's in front of just the regular x's. So that would be, for example, minus 4. Okay. A is whatever's in front of x squared, in this case nothing, so that means that a equals to 1, because you can imagine that there is an invisible 1 here. It can't be 0. But this is our a. I'm going to try my best to show that it's a. Yeah, okay. Maybe that's not a good idea. Let me make an equal sign and then write a over here. All right. Now, finally, there's C. And C is basically everything else. In this case, it's not just the minus 5, but it's actually also the k. It's minus 5 plus k. This whole thing here, I should really include the minus. This whole thing here is the c. It is a constant number that's added on. Okay, so let's put those in. Let's see what happens when we put it all in. So we're going to start with the b squared. That should be minus 4, but of course all inside a bracket, squared, minus 4 times, and then our a, that was 1, and then times, and then over here we have minus 5 plus k. All right. Okay, so we look at this and we go, okay, so when is this going to be less than 0? Well, it's a little hard to tell right now, so why don't we expand a little bit? Minus 4 times minus 4, that's obviously 16. Next we have minus 4 times 1, that's just minus 4. Minus 4 times minus 5, that gives us plus 20. But we also need to remember the minus 4 times the k. So that gives us minus 4k. So that should be 36 minus 4k, and then that should be less than 0. Okay, let's move this 4k to the other side so that we have 36, and then we say plus 4k to both sides. We keep this, and we say 4k over here. Then we can go, oh, but 36 divided by 4 is totally possible. And we find that we get this. Or, if you prefer, k is larger than 9. So as long as k is bigger than 9, that's when we have no real solutions. So now for the testing part. If you don't believe me, or if you don't believe this answer, you just have to think about the problem a little bit. I want to convince you that you can think your way out of this problem. So, okay, what kind of shape do we have here? We've got x squared. If we have a plus on this x squared part, like if it's plus there, if a is something positive, remember the shape of the graph looks like this. So, okay, that means that if you want to have two solutions, right, you have to be somewhere in this range. You have to be somewhere above the vertex. Okay, but the thing is, you can only have that if this graph is being pulled down. Suppose for a moment that it's being pushed up, like so, this doesn't have two solutions anywhere. And that's very possible. It's very possible to push this up by making k big. So basically, a k that is larger than some number, for example 9, that would definitely result in it being above the x-axis. It could definitely do that. It's basically a kind of a quick sanity check to make sure that this makes sense, and it does. The exact number, that's a little harder to argue for, but the idea that it must be a larger thing, like it must be k has to be bigger than this number, that makes perfect sense. Okay, so that's the approach.